Okay, I'm not sure what I hit, but I hit something and I stopped the video. So for part C, in part C, they want us to find the Taylor series. We want us to represent f of 1.2. So f of 1.2, they want us to approximate with three terms. The first three non-zero terms. And we have our Taylor polynomial, we have our Taylor series written, so we just need to take the first three terms and approximate it using those three terms. So, and because this is non-calculator, all we have to do is plug it in. So we go back up here. Our first three terms are right there. Those three terms. So I'm going to snag them real quick. Just going to lasso these. It's these first three terms. That's all we need. And I'm going to copy. We're going to slide down here. We're going to paste it in. I'm going to actually erase this and start over, but I'm going to paste it in right here. There we go. Those are our first three terms. So for part C, I'm just going to write part C, and then this is F. I want 1.2. It's approximately the 1, but we're going to put in a 1.2 right here. 1.2. And right here, we put in 1.2 minus 1 squared. And we don't actually have to evaluate it. We just had to plug it in. You can if you want, but you don't have to. It's an approximation. Once you plug it in, you don't have to do any more evaluation. You leave it right there. If you just plugged it in like that, that's another point. So the first four were really easy. If you can't remember how to do the interval of convergence, you do this one. That's a fifth point. You have just gotten 5 easy points. Really easy points. You could have get a 6th and a 7th. This one was, I thought, was really fair. And then the last part is part D. Part D. And in part D, they want us to approximate. They want us to show that the approximation is within 1/1000th of the exact value, which that has to be the error. Now, we know this thing is alternating, so it's the alternating remainder theorem. So we know that we just have to show that the error, oops, I can't write, it's too late. Error is equal to, remember, it's the remainder, and this is because we're writing, this was we did three non-zero terms, but remember this was the second, so this is really a second order, so it's the second order Taylor polynomial, so it's the remainder in terms of the second, so that's equal to the absolute value of the actual function at 1.2 minus the Taylor polynomial written for 1.2, and that's what that value up above was, which we don't have to worry about it. We just have to show that this is going to be less than or equal to the absolute value. Remember, we got to write it. We got to take the nth derivative, and that's that formula, right? So for the third term, notice, actually for the fourth term, we have the fourth term. We did it. Believe it or not. They wanted 3 terms. There we go. It's right. 1, 2. Actually, no, it's the next one after that. So we just have to plug it into the formula for the next one. So we'll plug it into the formula. That's okay. We know that it's -1. In this case, it's going to be -1 to the third power. And then it's going to be, let me go back to it. I want to make sure I'm not messing it. I can write it down, but I want to make sure I'm going from what they said. So it's -1, and then it's going to be 3 minus 1 factorial, because it's the third derivative. And then it's going to be over 2 cubed. All right, so that's the derivative. And then this is going to be times 3 factorial. And it's going to be the 1.2 minus 1 cubed. And if we look at this, see this is 2 factorial. This becomes 2 factorial. That's 3 factorial. You can simplify it. What I'm getting at is that, okay, you've done the analysis, right? You've got the error. Just by writing this down, you get 1 point. If you do the analysis, which means you got to simplify this. So basically, to simplify this, this is 2 factorial. That's going to cancel out with this and leave this as 3. All right? This is 0.2 cubed. All right? And you got a 2 cubed down here. Well, this is the same thing as saying, if we do our analysis, that's 0.2 cubed is the same as saying 2 times 1/10, right? Because 0.2 is equal to 2 divided by 100, which is 2 times 1/10, right? Oops, why did it jump all the way over there? Hang on, back down. There we go, came back. Okay, 2 times 1/10, right? So we can rewrite that and say that that's the same as saying 2 cubed times 1/10 cubed. 1/10 cubed, or 10 cubed is 1,000. All right? So I'm going to rewrite this. I'm going to say that this is equal to, well, -1 cubed is just -1. So it's -1 times, I already got rid of that, and I have a 3 down here. I know that. Then I have a 2 cubed here, and on top I had a 2 cubed, and it's times, and I'm just going to rewrite it. Since it's 1/10, I'm just going to go, so it's 1 over 1,000, like so, right? And then it's time, so that's, I've taken care of the 0.2 there, is making it as of 1 over 1,000, right? These cancel out. That goes to 1. And I end up, this is equal to absolute value of 1 over 3,000. Because the, we can say it's negative, doesn't really matter. That, 1 over 1,000, is most definitely less than 0.001, because this is 0.0003. Because this is, wait, this one, that's 1,000. No, yeah, this is 0. This is 3,000. This is 1 over 1,000. So that is less than. Make sense? And that's all you had to do. If you show that right there, you just have to write it like that. Like that. They would take this. You got all 9 points on this one. So, how did I do this? This goes back to that alternating remainder theorem. The alternating remainder theorem says that if I'm writing a Taylor polynomial, if I'm approximating a function with a Taylor polynomial of the second order, then the error is the next term that I chopped off. Because it's alternating, the biggest the error is ever going to be is when I take that first term and take the absolute value of it. So I do the next term. So this was for n, so it was 3, they wanted 3 terms. That's what they said at the beginning. I got lost in what I was doing. They wanted to use the first 3 non-zero terms. That's the n2. So this is n equal 1. This is n equal 2. So my error was for n equal 3. I plug it in, do the evaluation, show that 1 over 3,000 is less than 1 over 1,000, and I'm done. Easy peasy lemon squeezy. So hopefully this was totally unnecessary, and I just recorded these, and I don't have to go administer the English 2 test. But if I do, that was me doing the error again, and hopefully I'll be in class and answer your questions. If not, I'll answer your questions on Friday. So now, go try some of those worksheets.